The synthetic self. Unlocking the genomics of consciousness, or how information theory is transforming science. Virtuality 7. It turns out that the killer application for virtual reality is other human beings. Build a world that people want to inhabit, and the inhabitants will come. Charles Stross. Arguably, the key question that begs to be answered in our quest to understand consciousness is whether our self-reflective awareness can be algorithmically understood in terms of information theory, and thus is potentially substrate neutral, or is, as Sir Roger Penrose has long argued, the result of quantum biological processes which cannot, in principle, be computationally reduced. In the early 1960s, Dean E. Wooldridge, a research associate at California Institute of Technology and a director of TRW, laid out in his now prophetic book, Mechanical Man, The Physical Basis of Intelligent Life, strongly posited that if the properties of consciousness can indeed be shown to be precisely determined in rigid cause and effect fashion by the physical state of the associated material, then conscious phenomena clearly belong to the subject matter of basic science. The unusual properties of consciousness, which make it seem so different from quantities which we think we understand better, do not disqualify it for inclusion. Indeed, if concepts had in the past been excluded from physics when they seemed too bizarre or hard to comprehend, there would certainly be no relativity or quantum mechanics today. As such, we are finally ready to make the same transition from metaphysics to physics that was set in motion for the other functions of the body in the early 1600s. It was not so long ago that many people, including some very eminent scientists, such as Henry Bergson, believed that the secrets of genetics would never be revealed by biochemistry, because there was something inherently non-reducible in life's coding system, which was likened to a form of supernatural vitalism. But this turned out to be spectacularly wrong when Francis Crick and James Watson discovered the double helix structure to DNA and how 4 basic building blocks, adenine, cytosine, thymine, and guanine, comprise the fundamental language in life's evolution. It is the reconfiguration of these letters, as base pairs AT and CG, which make up our genotypes and which in turn determine the elementary differences between a dolphin, a human, and a grain of rice. What may have seemed unimaginable in the early 20th century, unraveling the billions of lines of code of a human genome, is now viewed as relatively commonplace. Is it conceivable that the mystery of consciousness may also have an informational solution similar to the genomic revolution? Christoph Koch and Giulio Tononi believe that integrated information theory, ITT, is the key to finally understanding how consciousness arises from complex chunks of matter. In this view, even though self-awareness is constructed from immensely varied but connected data streams, what we experience in our consciousness is integrated and thus differentiated parts come to us in a qualia gestalt. Hypothetically, this means that the amount of information that any system can compute at any given time is correlated to a conscious state. As such, this indicates that even though reductionism can indeed unpack the varying incoming data waves, the subjective experience of consciousness is experienced as a whole, and thus cannot be properly understood unless that totality is taken as a given. Another way of understanding this is that qualia may consist of any number of subroutines that contribute to its subjective character, but it is when those pathways conjoin which leads to an integrated sense of consciousness. Neuroscientist Giulio Tononi's PHI, A Voyage from the Brain to the Soul, summarizes it this way. Integrated information measures how much can be distinguished by the whole above and beyond its parts, and F is its symbol. A complex is where F reaches its maximum, and therein lives one consciousness, a single entity of experience. However, Koch's and Tononi's integrated theory shouldn't be conflated with Ken Wilber's integral theory, since the former doesn't invoke a spirit or consciousness first principle, but rather focuses on how material complexity, the totality of specific informational patterns, is coincident with self-reflective awareness. As Koch illuminates, it's not that any physical system has consciousness. A black hole, a heap of sand, a bunch of isolated neurons in a dish, they're not integrated. They have no consciousness, but complex systems do. And how much consciousness they have depends on how many connections they have and how they're wired up. Though this may at first glance appear to advocate a top-down approach, it is more properly adjudicated as an informational scaffolding project. where very close attention is given to neural complexity and the vast material interconnections necessary that give rise to varying levels of consciousness. Thus, it is the level of integration, not necessarily the compositional strata of that integration, that gives rise to awareness. This then suggests that consciousness is substrate neutral, which means that all sorts of non-organic material could potentially reflect consciousness, including the internet. As Koch controversially admits, but according to my version of panpsychism, it feels like something to be the internet. And if the internet were down, it wouldn't feel like anything anymore. And that is, in principle, not different from the way I feel when I'm in a deep, dreamless sleep. John Searle, who has been a professor of philosophy at UC Berkeley for more than 5 decades and is famous for his contrarian views on how consciousness should be studied, finds Koch's panpsychism to be unpalatable. In a scathing critique in the New York Review of Books, Searle writes, "But the deepest objection is that the theory is unmotivated. Suppose they could give a definition of integrated and differentiated information that was not observer-relative, that would enable us to tell from the brute physics of a system whether it had such information and what information exactly it had. Why should such systems thereby have qualitative unified subjectivity? In addition to bearing information as so defined, why should there be something it feels like to be a photodiode, a photon, a neutron, a smartphone, embedded processor, personal computer, the air we breathe, the soil we tread on, or any of their other wonderful examples? As it stands, the theory does not seem to be a serious scientific proposal. Both Koch and Tononi, however, argue that their theory is open to scientific refutation and thus qualifies as a serious scientific endeavor, contrary to Searle's doubts. In a recent issue of Wired magazine, Koch was asked, "Is your version of panpsychism truly scientific rather than metaphysical? How can it be tested?" To which Koch responded, "In principle, in all sorts of ways. One implication is that you can build 2 systems, each with the same input and output, but one, because of its internal structure, has integrated information. One system would be conscious and the other not. It's not the input-output behavior that makes a system conscious, but rather the internal wiring. The theory also says you can have simple systems that are conscious and complex systems that are not. The cerebellum should not give rise to consciousness because of the simplicity of its connections. Theoretically, you could compute that and see if that's the case, though we can't do that right now. There are millions of details we still don't know. Human brain imaging is too crude. It doesn't get you to the cellular level. The more relevant question, to me as a scientist, is how can I disprove the theory today? That's more difficult. Tononi's group has built a device to perturb the brain and assess the extent to which severely brain-injured patients, think of Terry Schiavo, are truly unconscious, or whether they do feel pain and distress but are unable to communicate with their loved ones. And it may be possible that some other theories of consciousness would fit these facts. Interestingly, and perhaps more revealing than one might at first suspect, the integrated informational approach has parallels, at least in part, with genomics and how complex DNA strands, when properly sequenced, give rise to organic life. As J. Craig Venter brilliantly illustrates in his latest book, Life at the Speed of Light, from the double helix to the dawn of digital life, life is an information system, and only when each part of that code is properly aligned can an organic cell properly function. Even the tiniest of errors, where just one nucleotide is misplaced, can have catastrophic consequences. As Venter explained when trying to synthesize the M. mycoides genome, having established which segment contained an error or errors that did not support life, we sequenced the DNA once again, this time using the highly accurate Sanger sequencing method, and found that there was a single base pair deletion. If this sounds as trivial as writing MISCI instead of mistake, equating nucleotides to individual letters is slightly misleading, in the sense that DNA code is read 3 nucleotides at a time, so that each 3-base combination, or codon, corresponds to a single amino acid in a protein. This means that a single base deletion effectively shifts the rest of a genetic sentence that follows, and hence the sequence of amino acids that the sentence codes for. This is called a frame shift mutation. In this case, the frame shift occurred in the essential gene DNA, which promotes the unwinding of DNA at the replication origin so that replication can begin, allowing a new genome to be made. That single base deletion prevented cell division and thus made life impossible. The informational approach evolves out of reductionism, not in juxtaposition with it, and should not be conflated with vitalism or metaphysics. Is consciousness as an informational coding system, defined by its integrated sets of computational interactions? Similar to genomics, where the real emphasis must be on how individual parts, be it neurons or nucleotides, combine and reconfigure to give birth to integrated complexes, be it a living cell or a conscious entity? Interestingly, Venter and his scientific team have discovered by their painstaking and labor-intensive efforts that life itself may also be substrate neutral, since they have successfully created the first synthetic life form. This breakthrough was only possible, though, by using sophisticated computer technology to digitally map out the complex coding inherent in tiny cells with simpler genomes such as the 582-970 base pair M genitalium. Of course, Venter and his team would never have even started, much less succeeded in their experiments, unless Watson and Crick had first unraveled the double helix structure to deoxyribonucleic acid, the basic building block to all life as we know it on this planet. Hence, even the most integrated of circuits must first be understood by unmasking its most fundamental of parts. This holds whether one is compiling the Oxford English Dictionary with its 26 letters from A to Z, developing the rudiments of computer processing, resting as it does on a binary number system, or making a wood-fried pizza, dependent as it is on a preconceived list of ingredients. Thus, and contrary to popular misconceptions, the informational approach, whether in genetics or neuroscience, evolves out of reductionism, not in contradistinction with it, and should not be conflated with vitalism or metaphysics. As Venter explains, DNA was the software of life, and if we change that software, we change the species, and thus the hardware of the cell. This is precisely the result that those yearning for evidence of some vitalistic force feared would come out of good reductionist science, of trying to break down life and what it meant to be alive into basic functions and simple components. Our experiments did not leave much room to support the views of the vitalists or of those who want to believe life depends on something more than a complex composite of chemical reactions. Likewise, Christoph Koch, who worked for years with Francis Crick on consciousness, Crick in 1994 dedicated his ultimate reductionist manifesto, The Astonishing Hypothesis, to Koch, and who was for many years a professor of biology at Caltech, hasn't abandoned reductionism simply because he strongly believes in Tononi's phi and the way of integrated information. On the contrary, Koch recently resigned from Caltech to take up his current position as Chief Scientific Officer of the Allen Institute for Brain Science in Seattle, Washington, where, among other projects, he focuses on studying the neural correlates necessary for human consciousness. A cursory survey of the Institute's sponsored publications should assuage any fears one may have that a phi approach is incompatible with inner theoretic reductionism. It should also be noted that information theory, besides now being elemental in genomics and neuroscience, is also championed by physicists as a fundamental way of understanding the quantum universe. As Seth Lloyd explained in his now classic tome, Programming the Universe, the universe is made of bits. Every molecule, atom, and elementary particle registers bits of information. Every interaction between those pieces of the universe processes that information by altering those bits. That is, the universe computes, and because the universe is governed by the laws of quantum mechanics, it computes in an intrinsically quantum mechanical fashion. Its bits are quantum bits. The history of the universe is, in effect, a huge and ongoing quantum computation. The universe is a quantum computer. If such is true, then what we are witnessing in differing scientific disciplines is how varying levels of computation or information processing evolve into sophisticated complex systems, ranging from the elements in the periodic table to mutating viruses and bacteria, to self-conscious animals to artificial intelligence guided by digital software. The implications of this underlying informational approach, however, are mind-boggling to say the least. What this portends is a holistic way of understanding matter and mind not by appealing to mythic animism, but rather by studying how intersecting bits of information cohere and create replicating forms of intelligent organisms. Or to put it more precisely, reductionism and integration are not dueling alternatives, but rather complementary pathways that necessitate each other. In genomics, Craig Venter predicts that in the future we will be able to transfer a complete digital blueprint via biological teleportation. When we read the genetic code by sequencing a genome, we are converting the physical code of DNA into a digital code that can be transformed into an electromagnetic wave that can be transmitted at the speed of light. The day is not far off when we will be able to send a robotically controlled genome sequencing unit in a probe to other planets to read the DNA sequence of any alien microbe life that may be there, whether it is living or preserved. Already, Craig Venter has had his own genome sequenced and broadcast into space. This was only made possible because of the unique configuration of his DNA, which could be translated into a digital record. Because Venter's genotype sequencing, as such, was substrate neutral, it allowed for a binary informational upload. If evolving forms of consciousness, like all biological phenotypes, has an informational blueprint of their own, then it too can be uploaded and transferred digitally provided that it is ultimately computational. In this scenario, self-reflective awareness is ultimately but one aspect of integrated information processing. This indicates that there can and must be a wide spectrum of differing internal states that correlate with complex chunks of matter, be it biological or digital. This is what is meant by consciousness being substrate neutral. As Koch elaborates, we live in a universe where organized bits of matter give rise to consciousness. And with that, we can ultimately derive all sorts of interesting things. The answer to when a fetus or a baby first becomes conscious, whether a brain-injured patient is conscious, pathologies of consciousness such as schizophrenia or consciousness in animals. We may also be able in the future to do precisely what Ray Kurzweil and other futurists have long prophesied, which is to reverse engineer the human brain and then transfer that information algorithmically into electromagnetic waves with the possibility of reconstructing it into different mediums which are not as biologically brittle as the human body. Nevertheless, Sir Roger Penrose argues that consciousness may be the result of quantum properties and as such cannot ad hoc be reduced computationally since there are non-algorithmic features inherent in the subatomic world. Others, such as the Nobel Prize-winning neurophysiologist Sir John Eccles, believed that the mind, or soul, was something quite distinct from the brain that housed it. As he stridently argued in Evolution of the Brain, Creation of the Self, I maintain that the human mystery is incredibly demeaned by scientific reductionism, with its claim in promissory materialism to account eventually for all of the spiritual worlds in terms of patterns of neuronal activity. This belief must be classed as a superstition. We have to recognize that we are spiritual beings with souls existing in a spiritual world as well as material beings with bodies and brains existing in a material world. Yet, Eccles' dualism has tended to be ignored by the general scientific community as a non-starter since a soul theory, by definition, is metaphysical and not readily amenable to confirmation or refutation. As Patricia Smith Churchland argued in her recent book, Touching a Nerve, back to my wisdom tooth. Can the dualist match neuroscience's level of explanatory consilience regarding why procaine blocks pain? Not even close. A dualist could say, well, the procaine also acts on the soul. But how, even roughly, does that work? What does it do to the soul? Especially if procaine is physical and the soul completely not physical. This dualist says nothing at all about mechanism. Consider the contrast with the neuronal explanation, which is all about mechanism. What is perhaps most exciting today about the scientific quest to understand consciousness is that so many avenues, even if contradictory, have opened up and been championed in various quarters. Whereas in the past, the subjective nature of human awareness was regarded as more or less a Skinnerian black box. Isaac Asimov, not surprisingly given his prophetic track record about most things scientific, captured the essence of informational theory when he analogized that selfhood was akin to a sandcastle on a beach. Yes, it is made of tiny grains of sand, but the architecture cannot be reduced to just one bit since it is the totality of how those bits are compiled that makes all the difference. Alter those grains and you can construct a moat. Alter them yet again and you can reproduce a tower or an underground tunnel. Similarly, the self is the result of a vast network of intersecting bits of matter, including neurons, synapses, dendrites, axons, chemical electrical fluid, etc. Without those integrated neuronal switches, human consciousness, as we presently know it, doesn't manifest, just as the sandcastle doesn't appear without its constituent parts being intact. However, if consciousness, like its sand counterpart, is, in terms of informational processing, substrate neutral, then one could, if he or she so desires, reverse engineer its coordinates and complex intersections and reconstruct it anew in an entirely different medium, provided such reconstructions were digitally accurate. We have already seen what this new, brave new world of information processing has done, and will continue to do, in the world of genomics. Since we have already created synthetic cells based on DNA coding, one can only wonder if in the not-so-distant future whether scientists will be able to construct a truly synthetic self. As Seth Lloyd concludes about the universe at large, the primary consequence of the computational nature of the universe is that the universe naturally generates complex systems such as life. Although the basic laws of physics are comparatively simple in form, they give rise, because they are computationally universal, to systems of enormous complexity.